So far in this unit, we have worked with 4 variables in DC circuits with resistive loads, and those are voltage, current, resistance, and power. And we've said that if any 2 of these variables are known, the other 2 can be found using these relationships. Ohm's law, V equals I times R. The power formula, power is current times voltage. We also have Joule's law in 2 forms. Power is I squared times the resistance, and power is also the voltage squared divided by the resistance. Now, in this example, we are going to work through that series of relationships. The circuit looks fairly complicated, but we're going to be asked to focus just on one component at a time. One of the things that we're going to notice here is that when we apply these relationships, power formula, Ohm's law, Joule's law, we need to use the circuit variables that relate to one of the components only. We don't mix and match a voltage from this component and a current for that component and so forth. We're concentrating on one component at a time, and we think about the power, voltage, current, and resistance for that component itself. So let's get started with part A. Here we are asked how much power is being supplied by the voltage source. Here's the voltage source. Let's write down the given information that relates to the voltage source. First, we have the voltage, V, is 32 volts. And then we also have current given here. This is the current coming out of the power supply. And so the current is given as 40 milliamps. Now, we're asked to find power, the power supplied by the source. Looking for a relationship between V, the voltage, I, the current, and P, the power, we can just use the power formula to find the power. So then the solution, very straightforward. The power, 40 times 10 to the minus 3rd amps times 32 volts, and we get 1.28 watts. That's the power being supplied by the voltage source. Now for part B, what is the value of R in ohms? So we'll look for the variable R in the circuit. Here's R, so it refers to this resistor. So its resistance value is labeled as R. And now if we know any 2 variables about this resistor, we can find the 3rd or 4th. So here we are given current is 8 milliamps, and we're given a power as 256 milliwatts. That's 256 times 10 to the minus 3rd watts. So we have 2 pieces of information about the resistor R, and so we can find the other 2 pieces of information. We're given power and current. We could find voltage and resistance. In this case, we're being asked to find resistance. So the relationship that we can use is Joule's law. Power is equal to I squared times R. Only we need to solve that for R, and so we will manipulate that algebraically. Dividing both sides by I squared, I get R equals the power divided by the current squared. And that's the form that the solution will take. So R is equal to the power, 256 milliwatts, divided by the current, 8 milliamps, and that's squared. And that is equal to 4 times 10 to the 3rd ohms, or 4 kilo ohms. So the value of this resistor right here is 4 kilo ohms. For part C, we are asked how much power is the 200 ohm resistor dissipating. Here's the 200 ohm resistor. We are given that it has 6.4 volts across it. So we'll write down that given information. We know R is 200 ohms, And we also know that the voltage across that resistor is 6.4 volts. Now notice that we're using the voltage across this component, not some other voltage in the circuit. We know this voltage, but we don't use that with this component because we're interested in the power dissipated by this component. So we have to use the variables related to this component, not some other variables from elsewhere in the circuit. Ohm's law, the power formula, and these relationships apply to a component. All the values must be with respect to a particular component. So we're looking at this component right now, this resistor. We're given two pieces of information about that resistor. We know its resistance and we know its voltage, therefore we can find its current and its power if we need to. In this case, what are we asked to find? How much power? So we're asked to find power. So then we need a relationship between resistance, voltage, and power, and we can use this form. Power is equal to voltage squared divided by resistance. Now we're asked to find power, so we can use it right in that form. So the solution then will be the power is equal to the voltage squared, 6.4 volts squared, divided by the resistance, 200 ohms, and we should get 204.8 times 10 to the minus 3. That will be in watts, and that's the same as 204.8 milliwatts. And that's the power dissipated by the 200 ohm resistor. In part D, we are asked, what is the voltage across the 470 ohm resistor? Here's the 470 ohm resistor, and we're asked for a voltage across that resistor. A common mistake would be to grab some available voltage from elsewhere in the circuit and trying to apply it to our component. So a common mistake would be just to write down 32 volts. But the 32 volts is associated with this component and not with our component. So when we do calculations involving our component, we want circuit variables that relate to our component. We've been given some information here. Let's write that down. First of all, we're given the resistance is 470 ohms. R is 470 ohms. And also the power being dissipated by that resistor is 481.3 milliwatts. That's times 10 to the minus 3 watts. Now we're asked to find, as we said, the voltage across that component. What relationship do we know that relates voltage, power, and resistance? Well, we know that power for a resistive circuit can be written as V squared over R. And we're trying to find this V. So let's rearrange that algebraically. I'll multiply both sides by R, and I'll get V squared equals P times R. And then I will take the square root of both sides, and I will get that the voltage we're looking for is equal to the square root of P times R. So then the solution, we'll write that V is equal to the square root of, the power is 481.3 times 10 to the minus 3 in watts, and the resistance is 470 ohms. And we'll take the square root, and I get approximately 15.04 volts. That's the voltage across this resistor with this polarity. The current flows through the resistor in this direction, causing this polarity of the voltage across that resistor. Finally, for part E, we are asked to find I. Where's I in the diagram? Here it is. So I is the current through this resistor. So let's write down information that we're given about that resistor. We're given that R is 330 ohms, and that the power being dissipated by that resistor is 337.9 milliwatts. And we're asked to find the current I through that resistor. What relationship do we know that relates current, power, and resistance in a DC resistive circuit? Well, we know that power is equal to I squared times R. We know power, we know R, so we're asked to solve for I. So to do that, we will algebraically manipulate this equation. We want to solve for I, so the first thing is I'll divide both sides by R. I'll get I squared equals P divided by R, and then take the square root of both sides. I get I is equal to the square root of P over R. And that's what we use to solve the problem. I is equal to the square root of power 337.9 times 10 to the minus 3 in watts divided by resistance 330 ohms. And when I did that, I got 32 times 10 to the minus third amps, or 32 milliamps. So there are 32 milliamps flowing through this resistor.